Have you ever stared up at the night sky and wondered, what are we really made of? Consider for a moment the vastness of the universe that stretches beyond the boundaries of our perception. It's a canvas painted with mysteries, a grand cosmic ballet that has been performing for billions of years. But what if I told you that the real magic happens behind the scenes, at a level so tiny it's almost unfathomable? Enter the realm of particle physics, a field that explores the smallest constituents of matter and energy. It's like a backstage pass to the universe, revealing the fundamental particles that make up everything we see and don't see. With particle physics, we can begin to grasp the building blocks of the cosmos, from the stars that twinkle in the night sky to the very cells that make up your body. If you've ever pondered these questions, welcome to the fascinating world of particle physics. So what exactly is particle physics? Well, imagine for a moment that you're trying to understand the workings of a complex clock. You'd probably start by taking it apart, examining each cog, spring, and gear to understand their individual roles and how they interact to keep time. In a similar vein, particle physics is the branch of science that disassembles the universe. It seeks to understand the most basic building blocks of matter and radiation, the particles, and their interactions. You see, everything around us, from the air we breathe to the stars we gaze at in the night sky, is made up of particles. But not just any particles. We're talking about fundamental particles, those that cannot be broken down further into anything smaller or simpler. Like the smallest essential cogs in our clock, these particles are the bedrock of all matter. Now, these fundamental particles don't just float around aimlessly. They're governed by forces, much like the way gravity keeps us grounded or the way magnets can attract or repel each other. In the realm of particle physics, there are 4 fundamental forces that dictate how particles interact and behave. First up, we have gravity, the force that pulls us towards the Earth and keeps the planets orbiting the sun. Then there's electromagnetism, which is responsible for light, electricity, and magnetism. Next, we have the strong nuclear force, which binds protons and neutrons together in the nucleus of an atom. Lastly, there's the weak nuclear force, which plays a key role in radioactive decay and nuclear fusion, the process that powers the sun. These forces, along with the fundamental particles, are the key players in the grand theater of particle physics. They are the cogs, springs, and gears that make the universe tick. In essence, particle physics attempts to break down the universe into its smallest, most fundamental components. Let's delve deeper into these fundamental particles. In the realm of particle physics, we categorize these tiny constituents of matter into 2 primary types, quarks and leptons. These are not just any particles, they are the fundamental particles, the smallest building blocks of all matter. Quarks are the more social of the two, always found in pairs or trios. They come in 6 flavors, as physicists like to say, and these are up, down, charm, strange, top, and bottom. Each flavor has a unique mass and charge. For instance, up quarks have a charge of positive 2/3, while down quarks have a charge of negative 1/3. These quarks, through their unique combinations, give rise to the protons and neutrons that reside in the nucleus of an atom. On the other hand, we have leptons, solitary particles that don't feel the need to pair up or cluster. Like quarks, they also come in 6 flavors: electron, muon, tau, electron neutrino, muon neutrino, and tau neutrino. The first 3 leptons have a charge of -1, while their neutrino counterparts are neutral. Electrons, as we know, inhabit the space around the nucleus, while neutrinos, elusive as they are, zip through the universe barely interacting with anything. These particles, each with their unique characteristics, are not just interesting to study. They are the very essence of matter, the smallest pieces of the cosmic jigsaw puzzle. They're responsible for the diversity and richness of the universe we see around us. From the stars that twinkle in the night sky to the very device you're using to watch this video, everything is made up of these fundamental particles. And yet there's so much more to learn about them. Despite our best efforts, we've only just scratched the surface of the vast, intricate world of particle physics. Our understanding of these particles and their interactions could unlock secrets about the universe and our place within it. These tiny particles, though seemingly insignificant, are the building blocks of the universe. But what holds these particles together? Enter the 4 forces of nature. Imagine a grand cosmic dance, where every step, every twirl is orchestrated by 4 fundamental forces. These forces, gravity, electromagnetic force, strong nuclear force, and weak nuclear force, are the invisible puppeteers, pulling the strings of the universe. Let's start with the most familiar one, gravity. It's the force that keeps our feet firmly on the ground, and the planets in their celestial paths. Yet of all the forces in the universe, gravity is the weakest. It's a bit like the shy wallflower at the cosmic ball, gentle and unassuming, but absolutely crucial in keeping everything in order. Next on the dance card is the electromagnetic force. This one is 1,000,000 times stronger than gravity. It's responsible for light, electricity, magnetism, and the structure of atoms. It's the force that gives substance to our world, preventing particles from simply passing through each other. Now let's turn our attention to the strong nuclear force. As the name suggests, this is the strongest of all the forces. It's the glue that holds the nucleus of an atom together, overcoming the repulsive electromagnetic force between protons. Without the strong nuclear force, atoms would fly apart, and matter as we know it would cease to exist. Finally, we have the weak nuclear force. Despite its name, it's 1,000,000 times stronger than gravity, yet it's 1,000,000,000 times weaker than the strong nuclear force. It's the force behind radioactive decay and nuclear fusion, the process that powers the sun and other stars. Each force plays a vital role in the cosmic dance, interacting with fundamental particles in distinct ways. From the tiniest atom to the vast expanses of the cosmos, these forces shape the reality we inhabit. These forces, though vastly different in strength and reach, work together to create the universe as we know it. So, why should we care about particle physics, you might ask? Well, the answer is as vast and intricate as the universe itself. Particle physics, in its essence, is the study of the fundamental building blocks of the universe. But it's not merely an academic pursuit. It's a journey of understanding how everything came to be and where it might be heading. From the birth of stars to the eventual fate of our universe, particle physics sheds light on these cosmic mysteries. This field of study is not confined to the cosmos. It permeates every scientific discipline, from biology to engineering. For instance, the discovery of the electron, a fundamental particle, led to the development of electronics, transforming our world in unimaginable ways. Similarly, the principles of particle physics are at the heart of medical imaging techniques like PET scans, helping diagnose and treat diseases. Particle physics also influences our understanding of energy. The sun, a giant nuclear reactor, fuses hydrogen atoms to create helium, in the process releasing vast amounts of energy. The fusion process is governed by the very principles that particle physicists study. Harnessing this power on Earth could lead to virtually limitless, clean energy, a holy grail for a world grappling with climate change. In a more philosophical sense, particle physics offers a lens through which to view our existence. It reminds us that we, too, are made of stardust, the same fundamental particles that make up distant galaxies. It's a humbling and awe-inspiring realization, simultaneously grounding us and highlighting our connection with the cosmos. While we may not see them, these particles and forces shape our understanding of the universe and our place within it.